All right, so let's learn how to calculate the energy transfer between different trophic levels. So what I referenced in the first video was the 10% rule. Each trophic level will only get 10% of the available energy from the previous trophic level. So this right here is an energy pyramid. So this is going to show the transfer of energy. So when you look at this, you can see that the energy is decreasing the further up the food chain you go. Okay? And the population is also decreasing. When you come up here to your top predators, you obviously have to have less predators than prey, or the food chain, the ecosystem itself will just collapse. So let's look at an example of this. So let's say you're given a problem, and you will be given these problems, but they're super easy, guys. It's just basically moving decimal points. Let's say you're given a problem where the producer has, it says there are 10,000 kilocalories of energy at the producer level. So moving up to the primary consumer level, we're only going to be transferring 10%. So what is 10% of 10,000? Well, guess what? You just knock off the 0 at the end. So now we're down to 1,000 kilocalories of energy at the primary level. So then moving up to the secondary level, so when the secondary consumer eats the primary consumer, we're getting 10%. So guess what? This 0 disappears. We now have 100 kilocalories. Now, moving up to the top level, when the tertiary consumer eats the secondary consumer, there's 10%, so we're knocking off that 0, so that leaves us with 10 kilocalories of energy. That is the 10% rule, guys. If you're given a problem where they give you a number with decimal points, you're literally just moving the decimal point. You're making the number smaller as you go up the energy pyramid. Okay, so this picture right here is showing you the relationship between photosynthesis and cellular respiration. They're two very important components within an ecosystem, and they are both dependent on each other. So photosynthesis, plants are making energy, they're making food for themselves in the form of glucose, using the sun as energy. As consumers, when we eat plants, we eat that glucose, which gives us energy. We then release carbon dioxide, which, guess what, the plants use. Okay? Plants also are going to be releasing oxygen, which we need as well. All right? So, we have the production of chemical energy here, which is glucose. All right? So, glucose gets eaten by the animal. And so consumers gain energy from producers. All right? Okay. So let's take this one step further. You're going to see the term productivity quite a bit in this course. And productivity basically refers to photosynthesis. How productive are the plants in an ecosystem? So primary productivity, we're going to write the definition up here. Primary productivity is the rate of photosynthesis over time. Rate of photosynthesis over time. Now, obviously, photosynthesis is going to be impacted by lots of different things. It can be impacted by the seasons. which are going to drastically change how much photosynthesis is happening, especially when trees are losing their leaves. There's not going to be a lot happening. So we have what's called the gross primary productivity and the net primary productivity. All right, so I'm going to get my highlighter tool for this. So the gross primary productivity is the rate of photosynthesis. Okay? It is the rate of photosynthesis. So let's make this a little bit more specific. It is the total rate of photosynthesis in an area. Okay? So this is all the photosynthesis that happens in one area. That's the gross. The net, let me get my highlighter back out. The net primary productivity is basically what is left after respiration losses. So when we factor in our consumers here, when we're eating the plants, it's what is left after the consumers are finished. So the net primary productivity is the rate of energy storage, the rate of energy storage by plants after subtracting energy loss to respiration. Okay? Now, the way that I think about this, if you think about your paycheck, guys, if you have a job, you understand that when you get your paycheck, you're not getting 100% of that money that you worked really hard for. You have taxes taken out. So the gross would be what you could earn, and the net would be what you're left over with after taxes are gone. That's basically how that works. Okay? So the way that this gets measured, so the net primary productivity, we're going to say the NPP, so remember this is what's left over. The net primary productivity is equal to the gross primary productivity, the total amount, minus what gets taken out from respiration. Okay? So these are problems that you would be required to calculate. But all this is, guys, is simple subtraction and addition. Okay? So the net, what's left over, is equal to the gross minus the respiration. Okay? Now, let's look at the units that this is measured in. So it's going to be measured in kilocalories per meter squared per year. Okay, so this is showing you energy per area per time. Okay, so that is the unit for measuring NPP. Now, what's important for you guys to understand is this also happens in aquatic ecosystems. You know that there are plants that live underwater, so you have the ability to calculate net primary productivity underwater too, because we have aquatic plants, so we know photosynthesis is going to happen. Now, when we look at plants, most plants are going to be near the surface, obviously, because there is going to be more sunlight. But if you think about the very bottom of the ocean, what's happening here? There are organisms here that obviously need oxygen to survive, and that oxygen comes from plants. So plants this deep have special adaptations. They have special adaptations. Now, when we look at photosynthesis, we look at two different colors. We look at red and blue. Everybody thinks that green is the most important color when it comes to photosynthesis, and it's not actually. Plants absorb red and blue light from the sun, and that's what drives photosynthesis. So you have the plants that are closer to the surface, they're going to absorb mostly red light. Okay? The plants that are deeper, remember they have those special adaptations. Blue light can penetrate deeper, and so these plants absorb mostly the blue light. Okay? So hopefully this makes sense in how aquatic ecosystems have photosynthesis happening. So this is going to be the end of this portion of the unit, guys. After this, we'll be moving on to climate, weather, and atmosphere.